Hello everyone, this is Ryan from High Desert Math Tutor, and today I want to take a moment to talk to you about dividing fractions. So the easiest operation we can do with fractions is multiplication. The second easiest operation we can do with fractions is division. Now you're going to see that it's not all that intimidating actually, even though at first glance it may feel like dividing fractions is going to be complicated. So it's very straightforward, believe it or not. So let's take number one right here. For example, whenever you're dividing fractions using this notation, it's as simple as keeping the first fraction the same. So we're going to write 3/4. We're going to change division to multiplication. But here's the key thing. We need to take the second fraction and flip it over. So instead of 5/6, we're going to put 6/5. Now, all we do is multiply. And remember, when you're multiplying fractions, you multiply straight across. So what we have here is 3 times 6 is 18, and 4 times 5 is 20. Now, this could be your final answer, even though this fraction is not in simplest form. And this video is not about simplifying fractions, so I'm not going to really focus on all the details here, but just for the sake of it, I'll show you quickly how you can simplify this fraction. So you may or may not remember what even and odd numbers are, but if you notice, 18 is even and 20 is also even. That means both of these numbers can be divided by 2. So that means we can get 18 by multiplying 2 times some number. So 2 times 9 is 18. Similarly, 20 is even, so we can get 20 by multiplying 2 times some number. And 2 times 10 is 20. So since we have multiplication on top and on bottom, and we have 2 on top and on bottom, we can cancel out these 2's. And all that's left over is 9/10. So this is the simplest form of this fraction. So this is the simplest form, and this is also an equivalent way of writing 9/10. So anytime you are multiplying fractions, you're going to keep the first fraction the same. You're going to change division to multiplication. And then the key thing you need to do is flip the second fraction. All right, so now this notation may not show up as often as you might expect, but it's very, very useful when dealing with more complicated examples. And number 2 below is a good example of something that may initially catch you off guard and seem to be overwhelming. So what we have here is 5/8 divided by 3/2. So notice, 5/8 divided by 3/2. No matter what this looks like, we can rewrite that as long as we make sure that after we write an equivalent way of, expressing this, when we read it, it still reads 5/8 divided by 3/2. So what we have here is 5/8 divided by 3/2. So 5/8, 3/2, and division. This is very important to remember because we just talked about how to work on this type of problem. And in most situations, it's going to be pretty easy to remember the process for dealing with this after you work 2 or 3 problems. So once again, we're going to keep the first fraction the same. So 5/8 stays the same. We're going to change division to multiplication. And the most important step to remember is we're going to flip the second fraction. This is very important to remember because you need the second fraction to flip from left to right. So now we're back to the easiest thing we could do with fractions, which is multiplication. And just multiply straight across. 5 times 2 is 10, and 8 times 3 is 24. Now, just like before, this is not the simplest form of this fraction, so I will show you quickly how to get to the simplest form. So notice 10 is an even number. 24 is also an even number. So that means we can get 10 by multiplying 2 times some number. And 2 times 5 is 10. Similar with 24, 24 is even. So we can get 24 by saying 2 times some number. And we can say 2 times 12 is 24. Now, because we have multiplication on top and on bottom, and we have a common number on top and on bottom that we're multiplying, we can cancel out these 2's. And the simplest form of this fraction is 5/12. So this is the simplest form of the fraction. This is an equivalent form of the fraction, meaning if you were to divide both of these numbers, say you divide 10 by 24 and you divide 5 by 12, your final answer would be the same. All right, so 2 more quick situations to look at when we're dividing fractions. So sometimes you come across fractions and you're dividing fractions by a whole number. This could come up if, say, you have 1/4 of a pizza and you have to divide it and give 5 different people a slice. Well, here, what we must do before we divide, we need to make sure both of the numbers we're working with are fractions. Now, 5 can be written by a fraction if we divide it by some number that doesn't change it. And the only number you can divide anything by without changing it is 1. So I'm going to rewrite this. I'm going to rewrite 1/4 divided by, but now I'm going to divide 5 by 1, turn it into a fraction. Now that we have 2 fractions, we're going to proceed exactly as we did before. So keep the first fraction the same, change division to multiplication, and then let's flip the second fraction. Now we can multiply straight across on top and on bottom, and we get 1 times 1 is 1, 4 times 5 is 20. And this is the simplest form of this fraction. So once again, if you are dividing a number that has a fraction involved and a whole number involved, you need to turn both of those into fractions before you divide. Now our final example, actually second to last example, for today, we're going to divide a whole number by a fraction. Just like before, we need to make sure we turn both of these into fractions before we move forward. So 3 is the same as 3 divided by 1. And we still have 3 divided by 1 is divided by 7/8. Now we're going to keep the first fraction, change division to multiplication, and then we're going to flip the second fraction. Now we have 3 times 8 is 24, and 1 times 7 is 7. And if we are happy with what is called an improper fraction as our answer, then this is the simplest form. And this is called an improper fraction. And it's improper because the numerator, the top of this fraction, is larger than the denominator. All that means is after we divide, our final answer is going to be some number that's bigger than 1. But the name of this is an improper fraction. The last example for today is one that I want to point out just because sometimes if we jump straight into dividing or doing computation in math, we may not realize how easy some problems should really be. Now, number 5 here, we have negative 2/3 divided by negative 2/3. So this thing sort of looks like a monster because it's a negative number on top, it's a fraction, then there's a negative number on bottom and another fraction. But there are a few things to notice. First things first, we're dividing a negative number by a negative number. And negative divided by negative is always positive. So if we wanted to simplify this a little bit right away, we can actually turn both these negatives into positives. Now we just have 2/3 divided by 2/3. If we really want to deal with this the long way, what we can do is rewrite this as 2/3 divided by 2/3. Now we can move forward just as we did before. We'll keep the first fraction the same, change division to multiplication, and then we'll flip the second fraction. And finally, we multiply straight across. I'll draw the little arrows. And we get 2 times 3 is 6, and 3 times 2 is 6. Well, here's where we could have jumped to our final answer a little bit more quickly. So 6 divided by 6 is 1. But not only that, anything divided by itself is 1. Now, what did we originally start with? We started with negative 2/3 up here divided by negative 2/3. So we're dividing negative 2/3 by itself, essentially. So if we were to just take a moment and not jump into computation, and we just ask ourselves, what is negative 2/3 divided by negative 2/3? We would notice, hey, we're dividing it by itself. The answer is automatically 1. So this is just a key to many problems, especially if you're working on a test such as the ASVAB. They're always going to be trying to trick you by throwing something in there that either you're not used to seeing or it's very easy, but the way they write it out distracts you from how easy the problem is. So remember to always take a few minutes, or not minutes, but take, 20 seconds to look at a problem and really just make sure you understand it before you jump into computing. Well, if you found this video useful, please like the video, subscribe to our channel, and if you find yourself needing help with a math problem, feel free to post the problem in the comments down below, and I'll do my best to make a video working on a similar problem as soon as possible.